All right, we'll go ahead and get started. My name is Peter Larson. I'm an assistant professor, College of Veterinary Medicine, University of Minnesota. I'm also co-director of the Minnesota Center for Prion Research and Outreach, MinPro, alongside Dr. Tiffany Wolf. We are so excited to be having this workshop today and be hosting Ani Belsiri here with us at MinPro. We think that this is such an important topic as CWD continues to spread throughout North America. Just a brief intro for Ani, and then we'll go ahead and turn it over to him and get started. So Ani is a disease ecologist with a background in veterinary medicine, pathogen modeling, and conservation research. He obtained his veterinary degree from Bombay Veterinary College, Mumbai, India, and his PhD from the University of Missouri. Currently, he is an assistant professor of disease ecology in the College of Forestry, Wildlife, and Environment at Auburn University. A major focus of Ani's research is on host pathogen systems that have public health and conservation implications. He uses an interdisciplinary approach that incorporates ecologic, epidemiologic, and model-based investigations to understand how pathogens spread through persistent and impact host populations. One of the main objectives of Ani's research is to translate insights gained from the analytical approach into actual outcomes for managers and policymakers. And today we're going to dig in this workshop to the exciting agent-based model of CWD. So with that, I'll turn it over to Ani. Take it away.
Thank you. Do you want to check if this mic is working with the Zoom people? Can you hear us? Can you hear me? Yep. Okay, great. So thank you, Peter. I am so excited to be here. We have been talking about, CWD and other exciting stuff for a long time. And these workshops, I have conducted these workshops for wildlife agencies. This is the first time I am doing it with researchers and scientists, and I'm really excited with that because it opens up a new avenue of us exploring together where we can collaborate, where we can use, where we can apply these models, these agent-based models. And one of the main goals of today's workshop is that the participants get to run the models on their laptops, on their computers. That is the main focus, because I have seen participants, especially wildlife agency people, when they came to the workshop, they were like a bit skeptical about, oh, this is too complicated. Oh, this is fine on a computer, but how will it help my questions or the issues that are important to me? But halfway through the workshop, they start asking questions like, can we do this with the model? Can we answer these questions with the models? And that's where it gets exciting. The philosophy overall has been in developing the models and in trying to adapt them to the needs of wildlife agencies. The main philosophy has been of a participatory modeling kind of thing. So it's not a modeler working in a lab, running the models and throwing out answers to the agency. It is the agency people are a part of the modeling process, the scenario design, the analysis of model outputs, and overall, basically designing the questions that we want to ask of the models. Having said that, I just remembered throughout this session, anytime, please interrupt when you have a question, when you have a suggestion. It's not going to be like a presentation. And you will notice I am not going to use a PowerPoint. So this is just a static web page, and you can access this. You have the link for it. So the most of the instructions are there, so you can follow along and you can click on the link. So one recommendation is when you get to a link, for example, you come to a link down here, don't left click, right click and open it in a new tab so that this web page remains. So for example, I can just do a right click and open in a new tab. And so the new tab should open here. Instead of just clicking on the link, it will open the link, but then you'll have to go back to the web page click on it again. Anyways, so a couple of, again, like 3 important points I wanted to make before we start with the model. First and foremost, I think this is all open science. All the model code, all the model apps, everything is available open access. So there is no licensing, no requirement for anyone to get any permission to use the models. That is the first thing. I hope with the documentation that is provided with the models, that it is a reproducible science thing. You can look at the code, you can recreate parts of it, although it requires a bit deeper understanding of the language, which is NetLogo. The main point here is you don't have to be a modeler, you don't have to be a coder to use these models. The interface, the NetLogo interface is very user-friendly. It is mostly sliders that you can use and set up the scenario and then run the model. We are going to look at some of the other features that help us run scenarios and then analyze those scenarios, analyze the model outputs, so as to not reinvent the wheel again. Like this is spatially explicit stochastic models. We do not use one run of the model. We maybe run it for 100 iterations or maybe 1,000 iterations at a time. So it generates a whole lot of data. And so as to make the models accessible, we have come up with Shiny apps. And so you can just upload the model output file on the Shiny apps and it will throw out the tables and the plots and everything. So you don't have to rewrite the code. And again, the idea is make it accessible as much as possible. The point being, this is all open science, all reproducible. Expectation from my side is like you just use it responsibly. It does not require you to make me a collaborator at any point of time. It is freely available, freely. I would love to collaborate, but that has been a point. Like someone from Canada once called and they are using the framework. And when I kind of insisted that you will need some training to use the model, they said, oh, we are all modelers and don't worry, we will make you a co-author on the paper. And the point is, even though I think this is a pragmatic approach in modeling such a complex system, it is still a machinery that requires some training to use. Otherwise, you can very well end into a kind of a dead end. And then it takes a lot of effort to get back to where you started. And it is essentially all the mistakes I made in the last 10 years that I want people to avoid. And that is the purpose of these workshops. It's not like I am teaching the participants anything. It is just facilitating the use of the model in a way that you don't make the same mistakes, right? So that was one point. So expectation is just that, use it. We'll be happy to cooperate and help in any way possible. The only thing I don't do, and I say this very bluntly, which I call fetch the stick game. And this has, I'll again be very honest, this has happened in some collaborations that I had in the past with wildlife agencies, wherein people would come to the meeting every month and say, okay, here's what I want you to do. Take this, go and do it, and then come back with it doesn't work that way. It is a participatory modeling thing. All involved people need to understand what questions we are asking of the model and what we are getting out of the model. And that brings me to the next point, which is the next 3 minutes I'm going to spend on, is demystification about agent-based modeling overall, but specifically on the framework that we have here. So first and foremost, this is not a predictive model. We do not get any predictions out of the modeling work. I have been asked, can you tell us where we will find CWD in this county? No, we cannot. Can you tell us what is the exact strategy to prevent CWD from getting established in my county? We cannot do that. No model in the world can do that, can give you, predictions in the sense of like, this is what is going to happen. What we do is forecasting. what we do is, given a set of conditions and assumptions, what is the most likely output that we will encounter, right? So in a very simple the simple way of understanding all of this is we can run what if scenarios. What if we implemented APR in a county? Will that result into more CWD in the landscape or less CWD in the landscape? What if we are implementing post-season harvest, culling, targeted culling in a CWD county? Will that help reduce the prevalence of CWD? And so on and so forth. There are multiple questions that we can frame the questions in a way that the model will give us some decision-making context. And that applies to research as well. And we will talk more about it. The next most common question is, how do I trust this model? And reviewers ask this question, is the model validated? And I frankly think this is the most ridiculous question ever, because this is like, this simulates a very complex system. There is no way in the world you could validate the model, right? What we have instead done, and what, of course, it's not only this model, all such models, we have verified the model. What it means is multiple reviewers who know the language, the modeling language, have reviewed the model programs and certified it to be doing what it says it is doing. So not the ecology part of it, the coding part of it, right? Then, like the real issue here is you don't have to trust any model, neither this nor any other model that you will ever encounter. What you need to do is, basically use the model. And what is special about this model is that you can put in your understanding, your assumptions about the system, about the issue that you are investigating, and compare the output. If you don't like what is being put into the model, you can change that. And that is, again, that kind of goes back to the participatory modeling framework. So I don't want this to be a black box, like you set the sliders, get a result, and lo and behold, this is the answer. No, you can at every point of time investigate what is happening, test all the model output. We have tools, so you don't have to rewrite the R code to look at like 10,000 lines of a CSV table. All of that is done. All of that is open access. So the point of the workshop is that everything is in one place for you to access, for you to use. And what we are going to start with is, run the OV-POP model, which essentially is a model that generates a realistic white-tailed deer population. And I will start with that. Before that, I just want to know if there are any questions at this point of time, any suggestions, if I am being clear, if I am talking with my very Indian accent and not understandable. I can try and talk a bit slowly, or anything you can, suggest. So any questions from the Zoom audience?
If there's any questions from the Zoom audience. If not, we'll get set up, and I think we will need to screen share.
Isn't this
Like,
already on the screen?
Well, no, because the Zoom will see, we need to screen share so the Zoom audience can actually see your screen. So
I thought we did
just a
that.
couple minutes, folks, and then we'll get this started. We're gonna figure out how to share this on Zoom.
Okay. Oh, I get it. Okay, so share, and this one, and share. Yeah.
All right. Yep. That looks good.
Yeah. Perfect. Okay. So let us start. And I think I just want to acknowledge Safari Club International Foundation in a grant that they kind of kindly, they support the workshops, the modeling workshops. And so far we have done them with a couple of wildlife agencies, and we are planning 2 more workshops in the next 2 or 3 months. With that, I think you guys already have downloaded NetLogo on your computers. There is a link there. If not, this is the link, and please right click so that it opens in a new tab. Then the Notepad Plus thing, it's not entirely necessary. It is required when you want to incorporate a new landscape in the model. And so if you don't have it, don't worry about it. We will take care of it later. The two models we are going to run today in the workshop, like you will be doing it on your computers, are the INOV-POP and the INOV-CWD. So these are adapted for Indiana. And I wanted to do a model for Minnesota, like bring in a landscape from Minnesota and run it for the workshop. But I just decided to go with the stuff that we already did. If there is any interest, we can do that, later on.
So you said for Indiana?
This is for Indiana.
Totally relevant.
Relevant,
Because as
exactly.
most everyone knows, and folks online, just last week, Indiana had its first official record of CWD in the state. So great state to start with.
Exactly. The first one is the population model, like so. Podocoileus virginianus population. That's how the OV-POP thing means. What we essentially do is we bring in the GIS information for the area of interest. And then that's an ASCII file. And then the model generates a white-tailed deer population based on the data that is available from the agency, including but not limited to harvest data, any demographic parameters that are available for the population of interest. And this is another kind of misconception about the agent-based modeling approach. I have encountered this several times. Every time a paper goes out for review, at least one reviewer comes back with, oh, how can the managers use this? There is so much data required to run these kinds of models. Absolutely not true. We can run the model with whatever data available, keeping in mind that the questions we ask of such a model will have to take into consideration what data is already available. And it will become more clear as we go through it. But the first model is to generate an in silico realistic white-tailed deer population. This is an agent-based model. So each and every deer in the landscape is represented as an agent. The patches of the model are 1 square mile. So we have like the patches as agents too. The patches, the deer interact with each other, giving rise to a pattern, an emergent pattern that we can then look at, analyze, study, and later on we introduce an infected deer into this realistic population and see how it spreads across the population over a number of years. Another thing we also do is we then implement some strategy, like increase antlerless harvest, or decrease male yearling harvest, or whatever, and then see how that affects the spread of chronic wasting disease in the population of interest. The second model is the chronic wasting disease transmission model. So this second model uses the realistic population that we generate using the POP model. We bring that population into the CWD model and then spread chronic wasting disease into this realistic population. And this is where I guess most of the questions come about, like how do we trust this model? And during the process today, hopefully we will get answers to some of those questions, okay? So now, if you have already downloaded the models, this structure of the folders on your computer, this is very important to understand. If you downloaded it, you should have in the folder, you have to extract all files. If you haven't done that, the downloaded folder, just go on there and say extract all. It will extract all these files, and then your folders within the folder should have a data folder, as you see here, right? A data folder, a results folder, the docs folder, and the code folder. The main model code rests in the code folder. Okay, the data that is required to run the model is in the data folder. And the internal thing might differ in your case. This is for a different model, but you should have those 4 folders extracted on your computer. Yeah.
That's for each, the off top and.
Yeah, yeah.
CW.
Yeah, yeah,
Okay,
yeah, yeah. Each one will have its own folder, and within each folder, you will have the 4 folders. Uh, what I'm going to next point out, and again, this is where attention to detail becomes very important. This is no rocket science, but oftentimes people starting to work on these models, encounter some errors, which everybody does, and then those errors result into a lot of time that is wasted. Just to avoid that, uh, one of the most important things to remember here is this overwriting part. So when you run the model, it writes a few, I think 4 CSV files. Those 4 files are automatically written in the results folder. Every time you run the model, even one iteration, it will write 4 files. 2 of those files, no matter whatever happens, they are written newly every time. But the other 2 are overwritten. So what I mean to say is, if you run the model right now, it will write 4 files into the results folder. And if you again rerun the model, 2 of those files, namely the dear pop die and the SA, the county name, those 2 files, it will keep adding to those files, right? So every time you run the model, some information will be added to the files. So what I'm trying to say, you run one scenario, and without clearing the files, if you run another scenario, your output files will have data for scenario 1 and scenario 2. Keeping in mind that we are going to automate the analysis of model outputs, the model output then will reflect a combination of 2 scenarios. We don't want that. So a simple solution, there are many solutions, but a simple solution, something to keep in mind, is you run 100 iterations of one model, go to the results folder, and just change the name of the output file. And I'm going to show you how to do that. It's simple. Like what I do, I am a bit lazy. What I would usually do is have this name and then here put _1. So the next time I run the model, the file is not overwritten. It will create a new file and write the data. So that attention to detail is very important. Otherwise, you run the models and you get outputs, and then you come to me and say, hey, it doesn't make sense. The results don't, really match with what we were expecting. It can be because of that. Another thing that I have learned after a lot of hours spent trying to figure out, it's such an easy solution, but it took me a long time to figure it. I just want to share it with you. So look at the model interface, right? This is the OVPOP model interface. I think what you should do is open the OVPOP model on your computers. So go to the code folder and just double click on the NetLogo model. If you are unable to open, just let me know, but it should throw up a screen like this, interface like this. And even not able to do that, let me know. Yeah, that's fine, exactly. Yeah, do not press the setup right now. It should look, it will not look like this. This will be a blank screen, the blank, interface there, but you should see the sliders and stuff like that. Right, you have it, everyone? So what I'm trying to say here is look at all this is called a chooser, because when you click on this, it should give you the options for the counties or for the regions that you want in your model right now. Is it giving any error there, Tiffany? Or oh, that's fine, but because you clicked setup right now, right? Or did you not?
The error came up when I first loaded it, but.
Okay, okay. And can you select, go to that one, yeah, and select? La Porte, the next one, yep. And then say click setup. And you can also move the slider all the way to right. Yeah. Now it should go, okay. Click on the code part there, the code tab, yeah. What is it saying? Not an agent set. Okay, what I will do is I will open the model here and let's see, does anyone else get an error? No, okay. Okay. Anyone on the Zoom? I see some chat there. Can hear, thank you. Okay.
Yeah, if at any time, it's a super informal, so if any folks on Zoom have a question, you can, raise your hand or go ahead and ask that question, interrupt, it's totally fine.
Okay, so do people on the Zoom, yeah.
We still see website.
Okay, so I need to change to that. Yep. Okay. There. And it should be here. Okay. So everybody should be able to see the 4 folders that I downloaded from the using the same link that you used. And if you have extracted everything, and if you go to the code part, you can then open in OV Pop. I will share this again. Oh, that's better, right? Okay. Yep. With that, I tried with a Minnesota county, but I'm going to go and recommend everyone use the La Porte County for the Indiana state. Up here is a speed slider. I recommend you keep it all the way to right so that it runs at the fastest speed. Do not change any other settings. And if you do setup, this should be able to bring up the La Porte landscape. And Peter here has an error. I need to figure out why it is doing that. So can you?
Anyone else able to get this? Okay, no.
No, who you don't get? You got it. Okay, okay. Oh, I think what it is. Can you close this and reopen it? It's kind of stuck there. Even if you change everything, it's not. So just reopen the code.
Right there.
Yes, yeah. And maximize it. Oh, it's still doing that, huh? You have extracted it out of the folder, right? Because if you haven't, that might be the reason, but I don't know. If you click on OV Pop, right click on that, it should say extract all.
Yeah, I decompressed it.
Oh, okay, okay.
Keep it on my desktop. But you can.
Okay, sure. I'll continue. I'll continue. Okay. So one of the main points I wanted to make here, keep in mind, and you will be running scenarios and all of that, that there are a lot of settings, right? This one here helps you select the counties that we have put in there. You can put a lot more in. Right now, I'm going to recommend all of you go to La Porte, right? We will talk about this later. There are a lot of options available. Do not use number 2 set parameters chooser or the selection button here. Just leave it like that. But as a user, you have the ability to change the post-harvest density, the doe to buck ratio, proportion of adults in the population, yearlings in the population. It automatically then calculates the proportion of fawns in the population, and then monthly rates for non-harvest mortality and yearly rates for harvest mortality. That is essentially what a user can do. The problem here is if you change the settings and run the model and store the output and then go back and then change the settings for another scenario and store the output. After doing that for 10, 15 times, you might not remember what a set of results represents. Does that make sense? Like, what setting did you put on for a particular set of results? To do that, what I have started doing is, when you set up your scenario, when you put all the sliders wherever you want them, you can just right click on the interface and say export interface. That will save the snapshot of the interface the way you have set it up as a PNG file, and you can save it into the folder where you are going to put in your results. So you will end up with every scenario, the results for every scenario, and set up for that scenario. So there will be no confusion about which set of results represents which scenario. If there is any confusion about scenario, I just want to point out a scenario is nothing but the settings that you put on here. So let me give you an example, just so that it's very clear. A baseline scenario would be running the model as it is with the calibrated data, right? The parameter setting. Then let's say our first scenario is to investigate the impact of antler point restriction. What that means is you protect yearling males from harvest. What that means from a modeling point of view, from this model's setting, is you go to MYHM, which is male yearling harvest mortality, and then bring that slider down to, let's say, 0.10, which means you are reducing the yearling male harvest in the population. So that is a scenario for APR. The scenarios can be as nuanced as you want, and I will show you a few examples of how nuanced a scenario can be. The point here being, there is a lot of data generated for every scenario, and you need to know what that data represents. It will be difficult to look into the output file and figure out what the settings were. You can do that. It's not impossible. Everything is being written down, when you save the data. But this is an easier way. Okay, go back. Right. So this was a point I wanted to make. You can export the interface by right-clicking on it. Okay. So what I now want to do is I want you to start running the models for our first part of the workshop. It's going to take some time. So we do that, and then we talk about some of the stuff. So except for Peter, everybody has the model out there.
I'm re-downloading that one. Set down.
Did it give a error because of it was 6.4?
I just got a black box. I just had black.
Okay, let me see. So just let me know, because some of those things are easy to kind of work around. That is fine. That is because you haven't done this. So if you try doing the setup thing, so it is giving you an error just like Peter. Okay, can you select the county there? Can you go back and select La Porte, this one, and then set up? Still doing that. Okay, go to the code tab there. And what does it say? Okay, okay, and it says What's the last part?
but got a number instead.
Okay, okay, is the same for you?
Yep.
Oh, okay,
There's people online.
with the same issue. Okay, okay, that is fantastic. Okay. Uh, So everyone has that problem. Not a single person has it the way you have it here. And then it was okay? Oh, okay. So that is the issue. I think what you need to do is go back to the. We can actually clear that. We can make that happen. But it's this point, download version 6.3.
But yeah, if folks online, download NetLogo version 6.3. I think some of us had 6.4.
And it shouldn't take long. It worked? Okay. 6.3 works. Okay, okay. Sure. Yes, so let's go to download NetLogo, open link in the new tab. And okay, here you can just change the version to 6.3 and put in your name, organization, and all those details and say download. Wow, that's a new thing that,
Always a wrinkle.
Yep. Does it work now? To work with 6.3, okay. And you can have multiple versions on your computer. You can select which one to use. So just make sure that you select 6.3 when opening the model. So clicking on the model, after you download NetLogo version, you can right click and say open with, and then go to NetLogo 6.3, even if you already have downloaded 6.4. Wow, okay. Just let me know when you have it already.
Yep. So for everyone online, yeah, we're getting all goods.
Okay.
It can confirm 6.3 works, and it does work for me now. Yes.
Okay. Okay.
6.3.
6.3. Okay. So what I really want to do is make two groups here so we can see the, rather than running one scenario and then running the other scenario, let's divide ourselves into two groups. Okay. Well, my right side of the room, let them be group one, right? And if you are group one, what you need to do is when you open the model, select the same county, La Porte, right? This one. And do not change any of the settings. Make sure all your settings like the post-harvest density on your tab is 14. The sex ratio is 160. Adult proportion is 0.45 and yearling proportion is 0.25. If you have it set that way, you are all set. You don't need to change anything. Okay. All the others are group two. What you need to do is The post-harvest density in group 2's case will be changed from 14 to 37. Change the slider so that it is 37. Then the sex ratio will be 120. And adult proportion will be 0.40. So you all have it, set it that way, no other change. So the difference in group 1 and group 2 is we start with a different density and different sex ratio. Okay, I want all of you to go back to your model, right, and just do a trial run, which means, and please ask the Zoom participants to select one of the groups. The instructions are all on there.
Yep, everyone on Zoom hear that? So there's two groups, and there's instructions that he just went over. Just go ahead and select one or the other.
Okay, you should now press setup. And once the button is back to the same color, right, you can then go and press go. And let me know if it throws up any error. And group 2 should do the same thing. Just one single run. If any error, let me know. Yes, what does it say? Okay, so I think you need to go back to code there and see what does it say. Okay, so it's still the problem. I think it's still opening into 6.4. So close it. Yeah. And you can go to the code and right click there and open with, and then select 6. Yeah, you need 6.3.
6.3. Okay.
Yeah. Yeah. Did it work for everyone? It stopped, like, so you see this kind of deer population plot, bachelor group size, two group size, and all of that. Okay, great. Now what we did was just one run. Okay, it's of no use for anything. So we are going to do 10 iterations, and there is a way to do that. But this is the most important step. Lest, you know, we go back to the folders here and click on the results folder. You will not see all these files because I did some extra runs, but you should see 4 files in the results folder. Do you see them? Okay.
So,
Yeah.
so I forgot to change the slider to faster.
Yeah, it's taking time.
So can I stop that?
No, you can just change the slider now. It
Yep.
doesn't matter.
So yeah, if you forgot to
Yeah.
move the slider, go ahead and move it.
Move it to
Yeah.
the right. Yep.
And then how many is there?
It just it will be done. So you will notice the number of years here.
Oh,
So
okay.
it stopped now. It runs for 26 years and then stores everything. So go to the results folder and just let me know if you have 4 files in there, right? You have, no, you don't.
Yeah.
You have 2. Oh, it's still running. Yeah, yeah. It has to, and you can change the slider. Yeah. That's fine. Yeah. Okay. Yeah. So the last 2 files are written when the last time step is done. So that's why. Okay. So I just want to very quickly explain what these files are. The file which is named post-harvest population Laporte version 2.2.0 is the file that we will be using in the CWD transmission model. Okay, so don't do anything to it. This other pre-harvest population model, we use it for the surveillance model. So it kind of goes and initiates the surveillance model. So we are not going to do any of that with those 2 files, the post-harvest and pre-harvest. These are the snapshots of the realistic deer population that you just created. It is in the NetLogo terminology, it is called export world. So it exports all the details of all the agents in the model so that you can initiate another model without having to run this to get the realistic population. And I'm going to talk more about it later on, but right now I want you to start the 10 iterations. So first and foremost, either delete the deer pop die Laporte and SA Laporte files, or just go ahead and rename them. simplest way to do that is, this is what I do. I would just click on this and _1 or _0 or something, so that this file is not accessed by the model anymore. If you don't want to get into that, just delete that. It doesn't matter either ways. Okay, once you have renamed or deleted, go back to the model. And this is an important step. You do that step, and then we are going to talk about by the time you finish running your model, right? So there are some other details I want to talk about. Group 1, keep your settings the same you did for the previous run. Group 2, keep them the same. Do not change anything. You have deleted the result files, right? Now, make sure your slider up here is all the way to the right. Right? This controls the speed of the model. So we want it fastest all the way to the right. Once you have done that, go to the tools tab here. Does everybody see the tools tab, the third from the left at the very top? Okay. On the tools tab, click on it. There will be a drop down menu. Come all the way down to behavior space. And Zoom participants, please type or chat so that we know if there is any issue. But you should all be here right now on the behavior space part of it. If you are there, click behavior space, and it will open another window wherein you will have to type the name of the experiment or the scenario. So click on new. Okay. Once you click on new, group 1 people, in the experiment name, delete this and type group 1 10. So group 1 is the name of your experiment and 10 is the number of iterations. Group 1 10, group 2 10. That is the name of the experiment. Do not change anything down there, but for repetitions, everybody see the repetitions window, type in 10 there. So you are going to do 10 runs, 10 iterations of the model. You don't have to just set up the experiment and let it go, and it will write all the outputs for 10 iterations in one file. Once you do that, come to this window which says measure runs using these reporters. Just delete that. We don't want count turtles. Just delete. The agents are called turtles. In NetLogo, agents are called turtles. And there is a history for that, but we'll talk about it later. But just delete that. We don't want that. Everybody done that? Go to OK. Click OK. It should open another window which shows your experiment name. So group 1 10, group 2 10. You see that? That is selected. Once that is selected, you have to click run. That will open another window. Do you see that window? Everything should be unchecked. There are 4, I think, selection options. We want nothing in the spreadsheet output. We want nothing in the table output. We don't want update view, so unselect that. It should be empty. We don't want update plots and monitors. Unselect that. Simultaneous runs in parallel should be 1. Just put number 1 there. And I will talk about cloud computing. This is just because we are doing it on your laptop. So 1 is very important. It should be 1. And now if you press OK, it will just run 10 runs in sequence and stop only once the 10 runs are done. So press OK. Any error, anything, let me know. Okay, good. Okay. So everybody just press OK, and then we'll go back to the main screen. Let it run. Do not bother NetLogo when it is doing that. We'll come back to this place. And I just want to talk a bit about what we are doing right now. Any error?
When you click one, it pops open this other screen.
Yes.
When you click run,
Uh-huh.
it popped over. And
Yeah.
opened another
And it
screen.
will tell you what's happening there.
Oh, so I leave that open.
Yeah, just leave that. It will stop only when all the 10 runs are done. Right. So I just want to explain what we are doing here. I have selected 10 because we want it done and we want to look at the results. Okay. Usually for the CWD Dynamics model, whenever we set up a scenario, we do a minimum of 100 iterations. So same settings, 100 iterations. And what that does is, because the model incorporates stochasticity. So each run gives us a different output. But collecting all those 100 outputs, we can then create a statistical portrait, which you will see later on. And that gives us meaningful information about our inputs, about how we are setting it up, right? So behavior space is useful because you don't have to do it every run, like set up and go and do it. More useful is cloud computing. You can put NetLogo runs on the cloud, and what takes, like, maybe it's going to take 15 minutes or 10 minutes on your computer would be done in like 30 seconds, because it distributes the instances and then you have all the data. When I started with the model in 2013, MDC wanted me to run the model for a group of 7 counties. So 7 real world counties. And so the number of deer, probably pre-harvest population, was 100,000. And it would take me 1 week to run 100 iterations. So the computer was on for 24 hours, 7 days. And at the end of 7 days, it would be done. NetLogo evolved in the next years. The same would now take 2 days. But with cloud computing, all of that is done in like half an hour. So there has been a lot of advance. This is one of the concerns agencies have had in the past about, oh, it takes such a long time to run the model. It doesn't really matter. But with cloud computing, you can do that in a jiffy. And it's very accessible now. It needs 4 lines of code. I think it's in Java, depending upon which cloud computing system you have. But I copy paste it. I do not understand Java at all, but it works. And we can talk about that later. Yes, you can do that, right? And you can even what they call dumping the memory of so you can allocate a lot more memory RAMs to the NetLogo program on your computer as well. But I am not much, in know about all those things, but you can speed up NetLogo on your laptops as well. What I mean to say is we are going to do a comparison of group 1 and group 2. I have it here, I have done it, but I want to see how it looks with your results, right? So once you have the results, once it says the runs are finished, what I'm hoping to do is you could either, what's the best way of sharing their screens, Peter?
Someone from group 1 would go on Zoom.
You can then share your screen, and then the group 2 can do that, right? And I can put all of that together here later. But the point here is you are right now, you have generated a population of white-tailed deer for this county in Indiana. And we will investigate the population structure, the deer population characteristics of the population that you have generated. And that is a very important process, which is the most difficult process for me to explain partners in this process, which is calibration. We want a realistic deer population. It does not come out like a magician pulls it out of a hat. We need to do a lot of runs to make sure that the population we have generated has the characteristics of the real world population. And briefly, I'm going to tell you, and this is again the misconception that I have faced a lot of times, which is about it requires a lot of data. And while your runs are ongoing, I'm going to show you this. You all can right click on this 4A, not 4A, I'm sorry. I don't want you to go to 4A, 5.1, model calibration, generating a realistic deer population, data request form. If you right click on it and open it in a new tab, this will pull up a form like this. And if you want to download any of this stuff, this is on GitHub. You can just use this download button. It will download on your computer. Okay. So anything on a GitHub repository, just download it if you are interested. But what it shows,
Sorry,
Yeah.
That file's in the main. Link to the website.
I
where
will,
those
I will.
files are.
Okay. So back to, I'll close this. Back to our main web page. Model calibration data request form. Right click, open in a new link, should open my GitHub repository, right? And it says data for ovcwd.pdf. If you see that and you want to download it, this is the download file thing. If not, you can access it anytime. What I want to show is this is what I share with the wildlife agency. Okay. There are a lot of parameters listed in column 1. What I always say is it's not necessary for the wildlife agency to provide all of this data. It's not needed. Whatever best data you have, just fill that part. And it can be an estimate based on a scientific study. It can be a guesstimate from some expert working with the agency. It can be an assumption based on studies done in the regional kind of deer for the deer population. Try and provide some reference, some comments about the data. And I can show you a pre-filled form. My point again here is it's not needed that we need to have all of this filled, right? So for example, if you see the first column is pre-harvest density, deer per square mile. Then you have post-harvest density. It's not essential that I need both. Anyone can do. Oh, we don't have an estimate for the public. That's fine. We can look in the book and see what the regional densities are. There already is a paper published on deer densities for the US. It's based on 2005 data. So they actually provide you county-wise deer population estimates for 2005. If your agency does not have data for 2024, but still wants to kind of look at the modeling part, well, we have 2005 data estimate available, right? And worst case, you have no idea what the density is. We can look at a low density scenario, medium density scenario, high density scenario. So there are a lot of ways you can investigate real world populations, keeping in mind that the questions you ask of the model should be cognizant of the fact that the data that is going in is very uncertain. It's still useful because what we are doing is a what if scenario, right? So we'll talk more about that. Yeah. You want to see that? It's very cool. It's a cool thing. I have it. I think I added it to the.
Folks on Zoom, we're gonna look at the database for the 2005.
Yeah, sure. I'll pull it up.
For the entire United States, yeah. But I think it might be a part.
Yeah, I remember where it is. Okay. Am I still sharing the screen? Okay. So here is this Pierre J article. Okay. white-tailed deer density 2003, I guess, but what you can see, the data that they have, yeah, here, this is 1982. And this is 2000, I thought it was 2005, but here. So mean statewide deer density is 1982 and 2003, not 2005. Yeah, so these are like some starting point, right? So if you want to look at Minnesota, what does it say? 3.5, right? Am I looking at the right thing? Right. Yeah, and so my point is, this is still, if nothing is available, you have something somewhere to start, right? And I think maybe, do you want me to share this paper?
That'd be great.
Okay, so I'll put it on the web page. Just remind me after we are done, right? Okay. Back to, in the meanwhile, has anyone's behavior space finished? You are done?
Yeah.
Perfect. So, Peter, you are done group 2?
Run 7 of 10.
7. Okay, we'll wait a few minutes. We'll do it together. Okay.
Ask students.
So my point is, you can please understand data requirement is absolutely not a constraint. Given that you and the agency and our research questions are all tuned with whatever data is available, we can make the best out of the available data. We have scope for assumptions, and I say this very responsibly. What you can do is use the what if approach for the uncertainty. You don't absolutely have no idea of the sex ratio in the regional deer population. You can see what it would mean if there was a balanced sex ratio. You can see what it would mean if you had a lot more females than males, or vice versa, right? Compare the results and kind of try and get to a reasonable point.
So Ani, in your experience of working with various state agencies, what what is the data like that you've encountered? Like,
yeah.
what has been available?
Sure. So I have had great experience with Missouri. And one of the reasons was they had already commissioned a statewide deer population study when we started the CWD work. So a fine scale data was available for most counties they were interested in for Missouri. With Michigan, the counties they were interested in, they had reasonable amount of data. All of this was reasonably available. With Indiana, we were able to work with some guesstimates, but again, they had an ongoing study, and now they have completed the study, so the models can be updated with the parameters. A couple of other states did not have this kind of data, yet it took a long time for us to come to this point where I was able to convince them that if you don't have data, you are in a completely dark room. This is not going to make everything right, but this is going to take you to the next step. At least understand what is important, right? If you want to make defensible decisions, you need a framework wherein you can support the decisions you make despite the uncertainty. So this is, I'm sure someone must have said this before, right? I think I came up with this, but I don't take me for, for what I'm going to say. We do not model despite uncertainties. We model because of the uncertainties. That is the reason why we model. If there was data available, there was no need for modeling, right? And so, every time a reviewer comes back with this, oh, but this kind of an approach requires a lot of data. And, this is okay for a modeler, but you cannot expect, wildlife managers to run this. I disagree. I think wildlife managers can run these programs, and they are running. Not all that I have interacted with, but I know some who really use this. And it's not only CWD. Think of setting targets for a county, harvest targets or harvest regulations for a county. You have all that is necessary, right? What if we increase adult male harvest by 20%? You can project the population for the next 10 years, look at it and say, if we do that, this is what you will see. So you have a tool which throws out the data, which can be used to make decisions. It's not telling you what to do. It's just giving you sufficient grounds to make your decisions. If information changes later on, update the model and put out the new output saying, well, this is a new information and now we have a refined estimate or whatever, right? So I think data requirement is one thing. Secondly, a comment I had from a very respectable biologist. I really like him. He was a great person in the workshop, asked the right questions. But when it came to like incorporating the model in their agency thing, he responded back saying, oh, you are all geniuses. We don't have any geniuses to run this kind of modeling. I disagree with that. I think, you know, there is a reason why NetLogo, the program that we are using, is so popular. It is popular because it is very user friendly. You can run it and it is very transparent. That actually leads into another rabbit hole, which I really worry about, and I'll talk about it later. But the point is, it is not data hungry. It is not highly sophisticated. You can learn to kind of, you know, you can, as in you guys, of course, but even a wildlife manager in charge of 5 counties, I would be thrilled if he has this on his or her laptop, and every time they interact with stakeholders or make any decisions, you know, run it for a county, see what the model says. You don't have to trust the model. It is just giving you one mechanism of investigating what is happening. That is the point. Anyway, is group 2 ready? Not yet.
I'm on the final steps.
Final step. Okay, great. We are there. So, okay, any one is done, that's fine. So what the Zoom people, are they ready to go to the next step? They can respond in the chat, so Peter will tell me. Or I can open the chat window here. All good, okay. All good, okay. So what we are going to do now is scroll down to number 4, which says automated model output analysis using the Shiny app we developed. And I just want to make this clear. You know, I might sometimes say I have developed. It's really a team of people. We have been working over 10 years, and usually in the PowerPoint, that is my second slide with all the collaborators. And so it's not me, we have developed this thing. Again, completely open access. Anybody can use it. So I want you to, the 4A does not apply to you today. I am going to provide you the login ID and password. You might think I keep talking about open access. Why do I have a login ID and password here? Because I host this Shiny app on my account. And if 200 people log in at the same time, I worry that it would not work if many people log in at the same time. And so I just have created a login ID and password. I give it to everyone. You just have to send in this requisition just so that the funding agency has, at the end of the year, knows like how many people used it. So again, if you right click on this and open in a new tab, it will give you a form which you can download, fill it. Simple, who is requesting, briefly, why do you want to use the framework? No other purpose but just to keep account of, like, you know, in the future, I'm hoping someone will sponsor the show. It doesn't take a lot of money, but taking it to the professional level so that anyone accessing it, it hasn't crashed, but I just don't want to, you know, be in that position. So if you come down and I'm going to show you the interface of the app, and then I'll tell you how to log on to it. But the interface of the app looks like this. Okay, you open the Shiny app, you will see a login window. You have to log in, and then this is all accessible to you. What you guys are going to do, group 1 and group 2, is the file written in your results folder, which starts with SA. So it should be SA La Porte. You are going to click on this one. It will ask you to select the file. You just select that file. And then you go to the other window here, tab here, and then upload the DearPopDive file. That's the only thing you have to do. The next step will be to set up the sliders, and I will tell you how to set them up. Before that, I want all of you to log on to the Shiny app. And the Shiny app address is accessible way below here on the web page, if all of you have access to the web page. If not, I will put it out here. We want to use this app, Shiny OVCWD. Does everyone have the link Okay, and I'm going to give you the password. The password is user122, that is the login ID, all small letters, user122. And yeah, and the password is *3, STAR3, no space. Just tell me if you can log into and see the Shiny app and see the screen. A *3, all small. Any problem logging in?
Maybe ask folks on Zoom. Or can you actually show?
Oh, I can. Yeah, sure. Yeah. So you are going to open Shiny OVCWD. This should open up, right? If you go down here, it says please log in, and I want you to put in user 122 and then *3. Done? Logged in? Great. Okay, perfect. Our friends on Zoom, login worked for me. Okay, perfect. Going back. The sliders that you see there, I will explain what you are doing, but please set those sliders before uploading your files. Okay, so the slider which says estimated pre-harvest population should be on 10,000, I believe. Let me see. I have a screenshot. Workshop. Target settings. Okay. Okay. So please set the estimated pre-harvest population slider at 10,000. Yeah.
So this, if I were to upload the essay report,
Yeah.
this information isn't in there. I gotta do this manually.
No, I'll tell you what we are doing. So if you do this, and you will see when you upload the files. This is not needed otherwise, but this helps you compare your model output result with the agency data. So does your model output match with the agency data? And you will see. So estimated pre-harvest population on 10,000, adult proportion in the population on 0.4, yearling proportion on 0.25, sex ratio 1.2. Am I going too fast? I have set it up the way your interface should look. Male fawn harvest and female fawn harvest at 50. That is the actual number harvested from LaPorte County in the year that we are model is simulating. Male yearling harvest 300, female yearling harvest 250. Male adult harvest.
I mean, is there a way to set like a male fawn harvest?
You can use the arrow. Just use the arrow button so it can be like fine. Yeah, fine. It is a problem, I know. It is basically because of the range, I guess. The 10,000 is like, and this is unusually small. So anyways, does it work, Peter, with the arrow? Male adult harvest 837 and female 500. Female yearling is 250. And so this is the actual data from the agency's report from whatever year we were working on then. Okay. Which one? Tell me. 837 is the male adult harvest and 500 is the female adult harvest. Okay. Once you have set this up, please upload the SA file on the left hand window and the Dear PopDie file on the right hand window from your computer, from your results section.
Yeah, folks on Zoom.
Sure. Zoom people, please let us know if there is any question. Login work for me. Were you able to set up the sliders on the Shiny app? Thank you. Okay. Right?
Okay, and just to confirm for everybody, this is the PDF that you showed, the best guesses from the agency.
Right.
The Shiny app.
Right. Exactly. And that will be clear, hopefully, in the next step. So what I want to do is, can someone from group 1 log on to the Zoom session? And it's fine if the Zoom people can do the same. Just let me know who is logging on. Where is the chat? Here.
Maybe Marie, I don't know if she was group. Hey, Maria, if you're, I don't know if you're group 1.
Either ways.
Either way, I
Whatever
mean,
she is,
maybe
she
you could
can
share your
log.
screen, Marie, for the next step.
And is there some way we can give the, I can stop, yep, I will. Stop share. Yep.
Right. He is group 1.
Okay, great. Are you able to share your screen? Or do you need she has a chat here, I guess. Oh, great, okay. Can you now click on the tab next to the instructions, which says OVPOP pre-harvest population? Yep. Okay, so what you see here now, this is group 1, okay, you people. Your output should look something like that. You can just reload it and you'll have to do all of that again. Sorry, login, user, what was it? User 122, and yeah, *3, and then just upload the, sorry about that. I guess it was on for a long time, yeah. I can tell you the numbers. You can just, 10,000 there for the first estimated pre-harvest population. And then adult proportion 0.4, and then 0.25, 1.2. You can use the, 1.2. Anybody remember the male fawn harvest? 80. 80 male fawn harvest, female fawn harvest 80. Yeah, and it's fine. It's fine if it's 79 or 81, doesn't matter. That is 300? 300, yep. And male adult harvest was 800, 837. Yeah, cool, that's fine. And then you go to female, which is again 80. Oh, 50, okay, yeah. Yeah, sorry. And then 250, or 200, 200 and 500. Okay, that's good. And this is just to give us an idea of where the model results lie, right? So you upload the file SA, first upload the file there, which is, and then that one is the Dear PopDie, and then go to OVPOP pre-harvest population, right? And what this is showing us is that the model generated population is way lower than the actual estimate on the left-hand plot. It is also showing us the lambda, which is the population growth rate, is fluctuating around 1. Can you also go and click on the OVPOP population structure? Yeah, that one. Yep. And that should give you the age structure of the population based on adult females, adult males, and so on. And these two windows are important. That is, those are the actual population parameters. One in blue is what the agency estimate says. One in orange is what your model estimate is, right? And that 0.71 is not correct, I guess. The adult proportion has to be 0.4, not 0.04. So that's why that is giving a wrong one. But anyways, look at the harvest data. In the model, we harvested a lot less number of male fawns and female and all of that. So let's compare this with group 2 data. So anyone from group 2? Yeah.
Everybody kicked off when she. Yeah, oh, I got kicked off. Okay.
No, but it's not because she's on there. It has a set timing that it kind of kicks you off. I need to change that. I have set it up at a, because what used to happen, I shared this and people would leave this on when they left their computers. And then for a long time, when I go on there, I see the log records. Somebody has it on their, I should have changed that, but that is a glitch. Yeah. Yeah. But group 2, can anyone from here share the group 2 data?
I need to put in
The slider data, right?
okay. So 10,000.
But you don't have to put that in, Peter. Just put 10,000 and go to the thing. We all know the numbers. We will ignore the first column and just look at the numbers. Just be sure that you put in the 10,000 because that way we'll see how the group 2 population is performing, right? Just upload your files. The rest of all we can look at the numbers and do it. So that is the SA. Sorry. SA Laporte file. And the second one would be the Deer Pop Die file. Yeah, and then you can go to the first tab, which is pre-harvest population, the very first tab.
Here.
Yeah. And what does it show? Look at that. The group 2 population is exactly where we wanted it. And the group 2 lambda is also like really close to 1.
So you're showing like a bit here
with the model data.
Yep.
And that process is the process of calibration. This doesn't happen automatically. I probably ran about 20 to 30 sets of numbers on the model to arrive at these numbers. And you can explore all the data there. Then go to the next tab, Peter, the population structure. And now the left-hand column will all say 0. You don't see that, but you can actually, look at you can go to there, yeah. And so the same thing here, it's just hidden, yeah. So now the adult proportion and the harvest numbers more closely match the real harvest numbers. And so what I want to highlight is it is a process of calibration that results into a population that matches with what we know of the real population. Once you have that population, that is the population we use to do our experiments, our virtual experiments with CWD. Does that make sense? So I now need to make a note of one glitch, which is the time you have on the Shiny app. As soon as he, okay, maybe that is the case. Only a few people can do that.
One person.
Oh, lot of users, right. And I guess if I go to the professional version, then this won't happen because they have those tiers, right? So maybe I need to do that. Find a sponsor for that, I guess. Anyway, I want to take a very small break here. Break as in, yeah, like you can have coffee and all of that. But I just want you guys to just think about what we did right now, because this is going to get us into the slightly more complicated process of for the next part. So I think I have summarized the results here for group 1 and group 2. The group 1 data looks like this. Group 2 data looks like this. The overlap, like, so we have a better number of populations. What did we change for group 2? We changed the population density. Like yours had 0.40 or 16 and theirs had 34 or something. Then we changed the adult proportion, right? And the sex ratio. to come at this point. The lambda is very important for the model. And I think why it is important is we do a lot of experiments in terms of harvest strategies, in terms of the spread of chronic wasting disease in the population of interest. And if you have an increasing lambda or a decreasing lambda, your results are not going to be comparable, right? So one of the requirements in my mind is that the lambda is 1 for your realistic population. It doesn't mean that you cannot investigate a population with less than or more than 1 lambda. Just be clear about what questions you are asking for that. We have done that with simulating chronic wasting disease endemic regions. Because in chronic wasting disease endemic regions, the population is already declining. And their lambda of 1 is not going to be of any use. But it has to be very clear when you interpret the results with a lambda of less than 1. Okay, but along with that, if you come down to the group 1 and group 2 population data, right? So my bad. Oh, I should be doing that. Okay. My bad. Here. There. Yeah, okay. So how do I take this out? Okay. So back to here. So this is group 1, N, abundance, and group 2. We calibrated it better and we had the better values for the group 2 scenario. So the population is matching. The lambda is much more closer to 1. And you can explore this further using your data. But the fawn proportion and all this was quite similar in both of these runs. But the harvest data, like, you had a significantly lower male adult harvest here, which came up again. The goal is not to exactly match these numbers, okay? Because these numbers change every year, the harvest numbers. But I don't want to have a harvest of 50 deer in the model when the real data is 1,000. So it has to be congruent. It doesn't have to exactly your calibration. If you have a lot of time, you can calibrate very, very closer. But again, keep in mind, we are actually not predicting. We are trying to do like a what if scenario, and comparison between scenarios is what is important rather than the absolute value. So it is okay to have about 700 when this is 830 here, right? But you can keep playing with the tuning of your OV pop model to arrive at a much closer, numbers. Doesn't matter, right? But should be comparable is the main point. So any questions so far? Any comments? Do you think this makes sense? So again, I want to just point this out again, not want to, sometimes when I do these workshops, it feels like I'm peddling wares. Hey, buy this, buy. It's not that. It's just that there is a lot of flexibility here compared to other models that are published. You can actually bring in any population of interest in this model. It doesn't have to be a county. It can be a larger area. It can be like a small part of a county. It can be a group of counties. You can run it for a state. That makes no sense. Don't do that ever. Yeah, it makes no sense. Like you cannot, really have any intervention implemented for a state. You can instead do it for a management unit or a county or, a reasonable amount. But just to say this, like just to compare, Florida, when there was this, which was the famous Katrina, right? That was in Florida, right? So which one was it? No, the Florida one, the famous one, the big one, I forget the name. It was like a 2016 or 20. Okay, so maybe I am mistaken, but there was one in Florida which required the agency to make decisions on evacuation of people from the areas that were supposedly, and the decisions were made hourly. The decisions were based on a NetLogo model, a real-time NetLogo model, which had all the state of Florida, simulated. And every hour with the satellite data, they updated the model, and the model identified areas of concern and areas. And so it was real-time, and they made real-world decisions using this model. This model looks like a video game. That is the drawback. So some people cannot take this seriously. You see those deer figures there and all of that, but it is pretty robust. It can go wrong. As you saw the error, like we used a different version and it started throwing an error. It's very easy to clear that, but that will always keep on happening. With every newer versions, I will have to go in and, just slightly tweak the code. But my point is, hopefully we have arrived at a point before we get into the real interesting part of CWD modeling. Like this is we are setting the stage. So we have a toy population model. And let's just, for now, say that you all agree with the characteristic of this in silico model. Having said that, you have all the control on further tweaking the OVPOP to generate a population that satisfies you or the wildlife manager. You don't have to take my word that this is it. You can still tweak it and have a more, fine-tuned model. But this is the stage wherein we'll lodge into the get into the CWD part of it, which is very exciting because you will now actually see the spread of chronic wasting disease. And more importantly, we will look at, if we do certain things, will it slow the spread of CWD? Can it prevent the establishment of CWD in the area that I am interested in? Yeah, any question?
So, okay, backing up here, but just to be clear, what's on the left side there, that's what we put.
That's what the agency wants. That's their data. We put it in there. Yeah, you are right. We use that. Oh, sure. Okay.
Yeah.
I will.
So what's on the left side, that's essentially what we put in when we just ran it.
Right.
And that's the info we have.
Right.
And then on the right side is what the model,
How the model population looks
right, after we ran it.
after we
The
ran it.
model population
Yep.
looks like that.
Yeah.
And we kind of want them to be
Matching.
similar.
Yes. Yep.
Okay.
And I will just repeat the question here. So on the left-hand side of all these tables or the columns, the blue columns are the values derived from data that is available with the DNR. Okay, those are the values we did not input any harvest numbers in the model. Remember, we have the harvest rates. The sliders are harvest rates. They are not the actual harvest numbers, right? We did set the density and the proportion of the age and sex composition, but the blue data is the starting point for the model setup. The process of calibration, we keep fine-tuning those values so that we arrive at values that are comparable. So group 1 was actually the actual starting point with the DNR data. Several runs were done, calibrations were done to arrive at group 2 values. Those group 2 values in the setup are different from what you have used, right? And that takes sometimes 30 runs or 30 sets of parameters, or maybe 100 sometimes, because things are not linear in there. One thing I found out, and which is very obvious to deer people, like people who have managed deer populations, but it is not a very straightforward thing in the model. So if you increase, if you decrease adult female harvest in the model, that's an annual rate, okay? So you are changing the number of females harvested every year. It changes the population structure drastically because you have a lot more females delivering fawns, and then everything changes. So changing that changes most of things. Changing only adult male harvest doesn't really make any difference to the rest of the stuff. And you can look at those associations. It's interesting, but it's very time consuming. Like if you essentially have to do a lot of runs,
To make a very large change.
or I am hoping I have a graduate student now. One of her chapters would be about like, these kind of guidelines for calibration. Like what would happen if you use this set of, if you change these sliders or these parameters, how does that affect the population total? So it has a very useful, I think, real world connection. Recently, Michigan deer biologist, he put out this, what is it called? A request to hunters about harvesting more does. So if every hunter harvests 2 more does, it's going to solve a lot of problems for the region, right? I ran that in the model and it doesn't work. It does not work. It's not linear. And all those things can be explored. Because again, this is something we talked about. There is an issue of compliance. When you recommend something to a larger group of people, not everyone is in compliance. If you assume everyone is in compliance, that is your baseline run. But what if only 20% people agree to that and then increase their harvest by additional harvesting 2 more does? How does that affect the population? How does that affect the structure? That's very interesting to see, right? Yeah. Yeah, that will help the Zoom people. Yeah.
If harvest decisions are made, because
Right.
the population model is run over a period of 26 years, but harvest-based decisions are changed on a more
Right.
frequent basis,
Right.
then how, then this kind of comparison isn't
Yeah.
really,
So
um,
that's a great
apples to
question. And
apples.
I'm glad you asked that because I would have overlooked that. So it's not necessary that you can only change this once in the model, the slider. You can actually add a line of code. We are going to look at that in the code tab, wherein you can incorporate this fluctuation in harvest every year. So there is a lot of flexibility with that. I'll tell you my issue with the model interface. Over a period of time, I realized the more crowded I make the interface, the more confusing it is to the lay users, right? I think already we have many decisions for the user here, right? I could add another set of sliders, wherein you can specify year-wise harvest for each of these things. I have made a decision consciously of all those nuancing in the code tab here. So we have the code tab. There are lines of code that can be activated to incorporate nuanced scenarios like you mentioned. One of the question was, what if we change the harvest period? Instead of December, what if we have the season in October? It was from a different state. And it had an entirely different impact on the deer population kind of dynamics. So it won't happen in the real world. But they had this, I thought it was a great question, like what happens if you change the timing of harvest? So that scenario is difficult to implement from the interface, but it's readily accessible in the code part.
I'm just thinking about, are you able to adjust the, 26 years is.
Oh, you
is-
can run it
there's
for
so
1
much
year,
value.
5 years, anything you want. So that year thing again, this year part that you have here, this
Mhm.
one, this, I do not recommend going beyond 15 years. Because as you go farther from your initial conditions, the variance is too much for anything you are looking at,
Mhm.
because these are stochastic models. So for the models where we make decisions on CWD, those are run for only 10 years. We are looking at impact. 25 years down the line, if the prevalence is going to be 50%, it makes no sense, because of all the things. You're exactly right. So this is the kind of the baseline version wherein we want to make sure. So if you look at the lambda plot, that's a great question though, because these are some things like, I really, you cannot see it, but there is a vertical line at year 15. right? So I try and find out when lambda becomes stationary at 1, right? So next time we want to run this, there is no reason for us to run the model for 25, the population model. We run it when this settles down, and we take a snapshot from year 15 into our CWD dynamics model, right? So the number of years you have to run it is completely up to the user. Yeah, and what this does is, again, I think this makes the modeling framework more portable. I haven't seen others do this, but what we have achieved by breaking it into 5 different models is the chronic wasting disease dynamics model is actually the same model that you ran. The only difference there is it has a contact matrix in it, and you introduce the infection. There is no difference. But if it was all put together, you would have to run the chronic wasting disease dynamics model until this settled, and then introduce your chronic wasting disease into the model. What we are doing, once we have the ready population which is matching our expectation, we are done with the population part. Anything to do with chronic wasting disease dynamic, we just use the snapshot. We save on those 15 years of model runs. The starting population. The starting population is not changing, but it will change if you change the harvest dynamics in the CWD dynamics model. It has all the same interface with some additional features, right? But the underlying population dynamics is the same. So you start with a snapshot of population that matches your understanding of the real world, and then you project that 5 years or 10 years or 15 years along with chronic wasting disease, along with regulations to control chronic wasting disease, and see the interaction result into a pattern that we can interpret as working, not working, no use, all of that. So there was in the I guess it was 1960s, the modeling thing was coming to the fore. And I might have to go back and read it again, but there was a rule called a rule of 2 out of 3 for the modeling thing. You can never have all the 3 things in one model. And it was, I think, realism, the generality that it addresses, and precision. You could have any 2 of them, but never all 3. Right? By breaking this modeling framework into different models, the framework has all the 3. Each model will not have 3, it will have 2 of 3. But the framework gives you the ability to have something that is precise, something that is very, very kind of, realistic, and something that can be generalizable. So, I think it's a neat way of also saving your model run time. And you will see the CWD dynamics model, we need at least 100 iterations. And that might take like several hours. So if you add the initial population dynamics to it, it will just, exponentially increase. So that is the point. Any other questions? What do you think after you had this brief, experience of running the model? I specifically selected a smaller county, so it shouldn't take long even with our laptops. But do you think, with more instructions provided to the user, do you think this is accessible? Like, can it be, I think, but, I would like to know what your first experience of running these models was.
Yeah, I think it's accessible. I think I keep going back to the data, being able to access data sets from the state, right? And that's critical, right?
Yeah,
for all of us in different
yeah.
areas to use this. But yeah, any comments from folks on Zoom or questions?
No. Okay. So I think we are halfway through with the first thing. Do you want to go ahead, want to take a coffee break, bathroom break, anything? Or just go ahead? Okay, sure.
Well, we're gonna break for 5 minutes and then dig into the next step.
That part. I just don't know what it's like in others. Oh, yeah, like, it's one thing to do sort of high top. Yeah.
You are right. It cannot work without them being on board.
Yeah.
I completely, I think you're right. Yep.
Depending on their structure, if they want to. Then, yeah, then you're like, something that's not real. That's fun.
Oh, the Lambda.
Just, yeah, why, you said something about it being one.
I'll tell you. And that will become clear when we look at the CWD dynamics. So what happens is, in the early phase of chronic wasting disease,
Yeah.
the prevalence remains well below 1%, right? It doesn't really have a huge population
Yeah,
impact.
right.
But once the prevalence goes above 3%, 4%, you do see a population decline in
Right,
those
sure, of
populations,
course, yeah.
right? Now, any intervention you do in that declining phase, like, by changing harvest, increasing harvest, actually results into accelerating the decline of the population.
Right.
Because CWD is killing them,
Yeah.
but you going and are actually removing non-infected animals, more non-infected animals than infected animals. And so it's further going down.
Yeah.
Right? In that case, the lambda is already less than 1. Right? And your interventions, even if they are sensible, rational, and all of that, they are actually contributing to further decline. But because the lambda was already less than 1, they are going down.
Right.
Most people do not differentiate between those 3 phases.
Right.
So anything that an let's say intensive harvest strategy in the pre-establishment phase
Gotcha.
would have a great impact.
Yeah.
But if you use the same thing later on, it actually does not work. It actually accelerates the decline. And so you just need to be aware of what the lambda is.
Yeah.
Because we were exploring all the pre-establishment phase interventions, I made a point to be aware of this lambda.
Yeah.
And because we are exporting this snapshot of the population, right? Think of another population where the lambda was actually increasing.
Yeah.
So it's a growing population. I use that snapshot, do something, and then looks like the population is growing despite CWD. It is growing because the lambda was already more than 1.
Right.
And CWD was in early phase.
Right.
So it might give an
Dynamics might change.
appearance that,
Yeah.
oh, well, this is working.
Yeah.
Well, in actually, it's not working. It's just the original lambda was more than
Yeah.
1. But I think, most biologists are aware of that, but policymakers do not understand
Yeah.
all of this. And so, again, not being condescending, but this is
Yeah,
too
no.
much of the details,
Yeah.
And so just specifying that, make sure that you know the lambda of the snapshot that you are using, just keeps a track of
Yeah.
what they are
Okay.
doing. Yeah.
That's helpful.
this place is amazing, like the room.
Isn't that cool?
Yeah, it's cool, yeah. Uh-huh. So when you said that, every time I look back and I thought someone had raised a hand, with that thing there. Like from the corner of my eye, when I like turn back, it looks like Christine is raising a hand and saying, "Hey, this is not working." But uh-huh. I have a student in my class, and she is very, very like super interested in diseases, and she has a lot of questions. So even when we are talking one on one, she like raises her hand, like like one-on-one discussion. And if I'm saying something and she wants to say something, she will like raise her hand and yeah.
I was looking at your surveillance paper.
Uh-huh.
And we're not looking at that model in this workshop, right?
I wanted to because I thought that was the most relevant for the work that you do.
Yeah.
And I just was kind of in a dilemma. Should I bring in the surveillance model or the, yeah.
It's the management model too. We are working with tribal partners.
Right.
And it might be great if we could
We can actually. It might just be not as polished as the material that I already have, but we can like maybe 15-20 minutes look at the surveillance models.
Yeah.
We'll do that. Thank you. Yeah. Those actually are pretty simple models. The surveillance models.
Yeah, that's
Mhm.
what I was
Yeah.
picking up on from the
Yeah,
paper.
yeah, yeah.
Yes.
Yeah.
Because you're just
Yeah.
distributing.
Yep,
surveillance,
exactly,
You're not
exactly,
actually transmitting.
Exactly. And we are doing some work with Texas people, and those models are really accessible. So I think I'll bring them up like in the second session. Yeah.
This looks like just the.
Do a 2-minute warning, 2-minute warning. All right, folks. Some great discussions here. Let's go ahead and pick this back up. We'll dig more into the CWD part of the workshop.
Yes, sir. Okay. Are the Zoom participants do we have them? Yep. Okay. So I think we are now we have about an hour, right? Until we break up. It's 11 o'clock, right? So what I want to do is now we have set this up. You already have the output from your running the OV pop model, right? Before we get into the details, I want you to start running the OVCWD model and then just let it run. It's not going to finish. We need 100 iterations, right? But we will just go through the basic mechanics of putting that on and then look at the other material that we have to discuss, right? And we can take that up in the second workshop as well. So I think you already have downloaded the OVCWD model. It should have a folder of its own, extracted, right? One thing you will have to do now, and I do not have my notes here, but let me remember. Okay, I think I did put in there. Okay, do you want me to open the model here and walk you through what you need to do? For folks on Zoom. Okay. So I might have to go there and do it, but with the mic on, that's okay. So what we are going to do is, first of all, go to the folder where you have INOVCWD. It should look like that. The same 4 folders, which is code, data, docs, and results. If you have that, the first step, and keep in mind, you already have a population after running your OV pop model. We do not want the population that the group 1 did, because it did not match with the expectation. So we want the file that group 2 has as an output, right? So someone from group 2, if you can, Peter, maybe you can send all of us an email, right? Or who can do it? Yeah, that's fine. Or if you want, I can share it, but I want it to be your kind of the file from your model runs, not from my model runs. Yeah.
The file that came out of group 2.
Yes. So Peter, it is going to be a file which is in your results folder, and we just want this one, the post-harvest population Laporte, right? What is the size of that file?
1.5 days.
1. Oh, okay.
Chat.
Okay. So once you receive that file, you have to copy and put that file in your INOVCWD data folder. Remember, data folder, not the results folder for the OVCWD. Okay, one chat. Okay, let's see. Yeah, okay.
device maybe.
And once you get that file, copy it and put it in the data folder for the OV CWD model. Okay, data folder. And Peter, you will have to do the same. Put it in the data folder. Once you have it, just give me an indication that all of you have it in the data folder. Chat. Okay, great. Once the file is in your data folder, please open the INOV CWD model. Yeah, right click and choose the correct version, the 6.3. So I could have done this before coming to the workshop, but I just wanted to give you a flavor of how do you incorporate newer things in the model. It's not that difficult, but just one step, right? Is this open for everyone? Is this giving any error, anything for now? Okay, good. Okay, now, first step is quite simple. I have already done it here, but I will get the instructions to you. So go on this CWD_region button and right click it. Just right click that. And once you right click it, click on edit. You probably will not see La Porte in there, right? That is because I left it for the workshop. So you are going to type in La Porte just the way I have done it here. 2 inverted commas and in between exactly how it is. L as a capital and P as a capital letter. Done. Click OK. Okay, apply. I don't think you need apply. Just click OK. And then maybe just confirm by clicking on the drop-down menu. Do you see La Porte there? Right. So what we did right now is we have just put in this as an option for the user, La Porte, right? But the program still cannot access that file. It is sitting in the data folder. But we want to write a couple of lines of code so that the program, when the user selects La Porte, we want to tell the program to open that CSV file. For that, click on the code button. Does it open all the basic code part of it? Right? Now, some of you might not see the line numbers. Who does not see the line numbers in your, okay. And that is one of the common, problems. I think it is very important to have access to the line number. So now, please click on Tools. Click on Tools. Preferences. And it should give you this thing, show line numbers in editor. Just check that box. The third from top, show line numbers in editor. Just check that box. Done. If you have done it correctly, you should be able to, if you click OK, you should be able to see line numbers. Do you see the line numbers now? Great. That is the best way to kind of interact with, yeah. Okay. No, let me see that. Anyone else got that?
So.
And go to the, oh, you don't have it there. You haven't typed it in.
Oh, down here.
Yeah.
And choices. Oh.
Yeah. And then, oh, my bad. Okay. You also got the same?
Yeah.
So,
Yeah.
Go back to the interface, right click on this one. Yeah. And edit. Yeah. And this thing actually goes in there, not there. That is CWD.
Can you show us on your screen?
I will. My bad. Sorry. So back to the interface. right click, edit, do not change the global variable, which is the CWD underscore region. That is the global variable that the program uses. Instead, type in this La Porte in the choices window down there. This does not change. You type it in here in the choices thing and then click OK. Others, you don't have the problem, right? Okay. And if you click OK, it should be back.
And then in the chat, if you look at the chat, there's if you scroll up a little bit, you can see there might be a different window to access some of these settings.
For Mac users, you can find in NetLogo settings. Okay, thank you. For Mac, right. For Mac, did you find it? Mac users? Yeah, good. Okay, thank you, Victoria. Fine. So just a reminder, put the normal speed to fastest on the interface. Go back to code. Does everyone see the code tab with line numbers now? Okay. I am not going to discuss any of the coding part here, but I think, anybody has any questions, especially about, coding those scenarios in, it's pretty straightforward. This is a high level language, so it's relatively easy. It's not like programming C++ or anything. So even if you haven't yet got any expertise in coding for NetLogo, it can still be very easy to add a few things. Okay, so just that, but I'm not going to talk about the actual coding part here. Now, we will scroll down to line number, I think it is 172. Line number 172. Does all your models on 172 say to set up -landscape, right? So that is the process where the model sets up the landscape for your selected county. What you now need to do is go to line 174 and copy everything from if all the way to this square bracket. Right click and copy. Enter and paste it just which will be now line 175. Right? And then just change the region name to La Porte here in the first part, and then just change the name of the file by removing Kankakee, just put in La Porte. I will highlight that with the mouse as well. So what you need to do is copy line 174, select it, right click, copy, and then come down to line 175, paste it there. Once you paste it, replace the Kankakee with La Porte in the first part of the line, which is CWD region is equal to, and then also replace Kankakee with La Porte in the file name. Two places where you replace La Porte. Done? Perfect. I think this is it. You have to go to File and say Save. Go back to the interface. Did any of you miss any step there? Are you back to the interface? Okay, now comes the main. Select La Porte from your drop-down menu. Here, select La Porte and click on Setup. Any errors so far? Okay, what has happened is the file that you copied, which was an output from your OVPOP model, is actually it is called export world. So all of the world, which includes all the turtles that are the deer and the patches and the characteristics of the deer and the patches, everything is written in a CSV file. That CSV file now sits in the data folder for your CWD model. And with this command, when you select Laporte, it is just importing all of that world into this. So what you have here, you don't see the deer here because it gets very crowded. So I have used a command called hide turtles. The turtles are hidden. But if you want to check, move your cursor or your mouse on any of the patches and right click. This is going to tell you the characteristics of the patch, like most importantly, because we use the GIS data, it tells you the characteristics of the patch that you are looking at, okay? Secondly, I think what you need to do, what I haven't done yet is, you all did setup? Okay. And let's do go. Press on go. Any error, anything that you see there? We will look at the interface later on. I just want to make sure that the model runs for 10 years or 15 years in this case. You can see the number of the year number and the month number in those windows there. No, it will. Oh, maybe. Okay. So I have made those changes here, and I guess that is what I wanted to demonstrate. So maybe let it go till 25. We'll change that. We want it to be 15 years now. There is no point in projecting anything beyond 15 years because of the variance. Like, it still works. It still gives you important data, but your 25 years are not yet complete, right? I just want to make, they're done. They're done for everyone. Great. Can you go and check in the output folder? So you should have a results folder along with the code folder, and it should have written a file which is named like this: cwd-inf-die la porte seed-inf_1. Do you see that file? Can you open that file? So you just did one run of those 25 years, right? And so you should have data for 25 years in the file written down. Mine is 15 because I have changed it from 25 to 15. Yeah. You don't have the headers. Okay. Okay. None of you have the headers. Okay. Okay. No, it's not. It's written by the program here. We'll check why that is the case. But the Zoom participants, do you see the output file? Do you see the headers, or do you not see the headers?
Like no headers.
No headers. Okay. Have the output file, but you see the numbers. Okay, yeah, we'll figure out the header part right now. I guess that will be an exercise into troubleshooting. We need the troubleshooting to be, yeah. Oh, you know why that happened? Because you did not clear your first file. And that is why you don't see the headers. Right, so let's go back. Let's try it one more time. My bad, I should have. Yes, so I'm going through. So select the file that you have in your results folder. I am just going to delete that. Everybody please delete the file. There should be no file in your results folder, right? Okay, go back to the code folder. Okay, in the code folder. Oh, you already have your model open, sorry. That's already open, right? Okay, so this is the wrong model. I need to close this. Cancel. Just a minute. Discard. Okay, sorry. So now you have your OV CWD model, right? Selected Laporte. We have deleted the results file. So let's do setup again. Oh, let's bring it down to 15. Okay, let's do that change right now. So go into the code part, code tab. Please look at line number 184. Does it say if x is equal to 300, stop in your part? Just change that 300 to 180. So each tick is a time step. And the time step for the CWD model is 1 month. All the things happen in 1 month steps. So with 180 months, we run it for 15 years. With 300, we run it for 25 years, right? So if you want to run it for 10 years, Tiffany, this is where you can actually change. And whatever you see after a semicolon, that is a comment for the user. The model program does not read that. So I have put in a comment here, model is simulated for 10 years, set at 120. So if you change this to 120, it will run for 10 years. Right now, we want to run it for 15 years. So we set it at 180. Does that make sense? Right? So you have changed line 184. You also need to change another line where the file is written, right? So go down to line number. Am I making this too complex, too complicated? Please tell me, whenever you want me to slow down or anything like that. You should look at line number 359. Line number 359 is where we kind of reset all the parameters and then write it in a file. So in your case, it will be reading 299, right? It is just the year before we want the model to stop. We kind of set everything back. So just make that 179, which is one less than 180, right? I should have done this, but there is an easy way of doing this. I could have just given that value, number of years, make it a variable. So the user can, on the interface, say, I want to run this for 15 years. Then that variable becomes 15 into 12. And then the values are automatically put in there. That's so straightforward thing to do. But keep in mind, I have been working on this model when I learned NetLogo 15 years ago. And much of the code is, I just kept on adding to it. And this is such a simple thing to do that I feel so stupid at this point of time, having you to go and change all. And this is a source of error. This is wrong as a programmer, this is wrong. Because if I forget to change this to back, then it's going to write different things. But okay, right now 359, make it 179 instead of 299, right? Hopefully this should work. Please, there is a chat in there. Okay, please go to save, file, save, interface. Let us all select La Porte, setup, and go. Now, which just changed because you deleted the output file. So hopefully this time it should write the headers. We'll see. If not, we can still figure out.
Share my screen.
Oh, great, please. I can stop share. Error. Okay. And it's done, right? Yeah. I was going to. Yep. Yeah. So now this is Peter's screen that you are looking at. And I want to spend some time on what you are seeing there before I ask you to start with a 100 iteration thing. Am I blocking your way in any way? I just find this easier. Okay. So, okay, I see what Peter has. Okay, great. First and foremost, not all of your screens would look like that. Does anyone have a screen with no yellow patches? Nobody? Everybody has yellow patches? One yellow patch and no number on that. No number like this on that yellow patch. Okay, So that is great. Okay, so first and foremost, what is happening here is this is a stochastic model. All runs do not have the exact same outputs. That is why we do 100 iterations or maybe 1000 iterations. Let's first understand what you see here. So this model ran for 15 years, right, in monthly time steps. If you look at this part on the interface, and Zoom participants, please intervene at any point of time if I am not being audible or if I'm not clear. Oh, my bad. No. Just that I just want to highlight this part. Yeah, this one. This between those two dashed lines. So you now have the control as the user to select who introduces chronic wasting disease in this population, right? For now, you have selected the yearling that dispersed into this population. So dispersing male yearling. This current run was simulated by bringing in a dispersing male yearling which was infected into the population. If you go to this plot here, just scroll down, the disease was introduced right in the first year of the model. Dispersing male yearling walked into our population, was infected, right? And then the rest of the stuff that happened is a stochastic process of who does he interact with in the model, and when is he harvested, or when does he die, and all of that, right? So can you go back to that the screen that we have, the yellow patches and all of that? So each yellow patch represents a 1 square mile area in our region of interest that has or has had an infected deer occurring on that patch. In Christine's case, he just has a yellow patch. What that means is there was an infected deer there, but that one was died or was harvested and removed. The patch remains yellow to tell us that at some point of time during these 15 years, there was an infected deer on the patch. The ones on Peter's screen you see, you see the numbers. The number represent currently when the model stopped, how many deer on that patch are infected, right? So it tells you after 15 years of CWD spreading into the population, you have had most patches you would see there is 1 or 2 infected deer. You do see some places where you have more infected deer. There is an orange patch you see up there. All of you should see an orange patch. That orange patch is the patch where the dispersing male came into the population, walked into the population. Does that make sense? Okay. Now, here is another slider, which is seed infection. And this is a question kind of related to what Tiffany asked earlier on. You have the control. In this case, there was just 1 introduction in the first year. You have the control to set the frequency of the introduction, like La Porte County or La Grange Country, Indiana, where you detected the first one is neighboring Michigan. One of the scenarios they were interested in, what if a few infected deer walk into our state every year, right? So that is very easily adjusted using the seed infection. There is another feature here, which is much better in another version of the model. I didn't want to, as I said, bombard you with a lot of sliders and a lot of information. But if you look at the slider on the top here, this is a new slider that was not on your OVPOP model. This is the targeted culling percentage. Some agencies are interested in exploring, like you have detected CWD. Now, what if after every harvest season, we send in sharpshooters and shoot like n number of deer with the idea that it brings down the local density and then reduces the contact between deer, and so you would probably delay the establishment of CWD or eliminate CWD. That is the idea. So to test that, you have a slider wherein you can use targeted culling.
This is something our DNR does.
Oh, right. Yeah. Is there a question?
Barb, can you hear us, Barb? We were just wondering what Minnesota DNR's targeted calling percentages in the Southeast. Do you have? might you know that percentage?
The percentage of deer that are cold? Or
Or the targeted, yeah, what the target is, like what, how many individuals that the DNR wants to call out, right? Each season, is that right, Ani?
I don't know that they have targets, Peter, but I can check on that. I have a feeling they don't have a target in mind, but I can check.
Got it.
And I can kind of bring up on the screen some of the commonly used strategies. So for example, just if you are interested and if you know the way we set up targeted culling scenarios, it's pretty interesting. Can the Zoom people see the whiteboard if I write something on that?
Probably not. You have to change the
Okay.
camera view to like zoom in on it somehow.
I think that is two. You want me to try that or just explain here?
I mean, you can explain here.
I'll try and explain. If they don't kind of get it, I can bring in the board. But there are two main factors in this post-season targeted cull. Almost always, it is around a new detection of chronic wasting disease. So you go in a county and find one positive. Let's say county X, you found a positive this year. So the idea is you decide on a radius around that positive that you want to do post-season targeted cull. So that is the first factor. And the second factor is the intensity of targeted cull. And you can usually translate it into a deer per square mile, right? So do you want to cull 2 deer per square mile or 5 or 10 or whatever? The third sometimes used is they decide on the age sex selection. So do you want to cull all individuals fitting that description, or do you just want to focus on antlerless or antler? So three factors can help us set up the scenario for post-season targeted culling. Okay, we have evaluated post-season targeted culling for 1 square mile areas, 5 square mile areas, 9 square mile areas, and 25 square mile areas around the new detection. And intensities of low is 2 per square mile, medium is 5 per square mile, and 10 is high intensity, 10 per square mile. So you go in there with sharpshooters after the harvest season and set a target of 10 deer per square mile in a 25 square mile area around the new detection, right? And so we evaluated those strategies. We'll look at it later in the thing, the results. But what I want to highlight, and we have come to a point where we really need to actively talk about this, is I am limited by what inputs I have got over the last 10 years. I'm damn sure that like you people or other people are a lot more creative with questions that we can ask of such a model, right? So at any point of time, if there is any question, just like the way you asked about, can we change this? Can we change the duration? Can we change? So for almost all the questions, I will say, yes, that can be done. And I mean it. It can be done, right? But one of the things I always thought, like I'm just want to give you an example, okay? It might be a bit of a digression, but it's important at this point of time because beyond this point, we will mostly be talking about, can this be of any use to you people, to people on the Zoom? And what is it that I can do to facilitate the adoption of this model for your purposes? I go back to the first point I made. There is no requirement that I have to be a collaborator, that I have to be a co-author. I am more than happy to collaborate, but if you just want information from me, if you just want coding help from me, I'm all there. No strings attached, first and foremost. So do not be bothered by like, oh, this will mean that we have to do this or nothing. You ask me, this is like my, I would say like passion. And so anything, any creative use of this, I am all for it.
So Ani, like we're using Indiana here as obviously an example, but down the road, you have county level data for Minnesota.
Yeah.
Really, that we can just pull right into this?
I want to do that in the second workshop, want to bring up a Minnesota county. We might not be able to get it in here and have all of that done today, but just to show you like how that can be done. Getting back, okay, confirmed, do not have any, okay. It's a pass.
The rest of that chat. You can, yeah.
So Barb says, confirm we do not have any specific goals for culling. We select our focus areas based on past positives, but once we have identified an area, there's no limit of deer we would remove unless the landowner applied limits.
That's great. Okay. 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 So one of the things I have missed, I really wanted to bring that into the model, but it was beyond my control. These collaborations take a direction of their own, but something I guess you guys can definitely, because of the work you are doing. What is kind of a low-hanging fruit with this kind of a modeling workshop? Right now, look at the landscape. We just have % forest cover into the model landscape. It is very easy to get in other geographic features like water bodies, built-up structures. Yeah.
Oh, sorry.
No, go ahead.
I think you're gonna get that.
Yeah. So that is something that, I don't want to say it will make the modeling more predictive, but I think we can ask a lot more nuanced questions. Once we don't have to change anything in the model, like not many things change, but we can get in a lot of landscape features in the model, which will then help us understand the hotspots on the given landscape, right? Right now, there is no way. Imagine this was Michigan and there was a large water body, like, a part of the county, right? So there are ways of getting all of that, all of the geographical features in the model landscape without changing much, giving us a much more better idea of where deer occur and where we might see a lot more contamination in the landscape and things like that. So that is the direction. I think I haven't done anything so far. I do have a submodel for environmental contamination. So prions in the landscape, you see the yellow patches right now, okay? They just indicate where you had an infected white-tailed deer, one or more, and they are not there anymore. But if you add in the environmental transmission submodel, it then actually starts showing you prions on the patches. They are not what we spoke yesterday. Yeah, so they are not like, they will just indicate that this patch, 1 square mile patch, has prions on them. It does not tell you where on that patch, right? You cannot go below 1 square mile in this model. It can still be changed to, like, you can have a 2 meter by 2 meter patch, but that will require a lot of changing for all the processes that we have. So in future, if we come to some sort of a kind of an agreement of what level of refinement we want in here, it can be done. Yeah.
So and Ani and I were talking over dinner last night about this. We have some exciting environmental data coming out of MinPro, both for tracking prions in water. They're bound to sediments, and then you can model where those sediments are going and maybe being deposited downstream of positive farms or positive regions, within a particular county. So Ani, you think that in future iterations of this, we could actually incorporate some of the, what we're learning here in Minnesota about waterways, like moving prions throughout the environment. Some of those factors can be input into this?
I think so. And again, I just have to preface this with, it still will not be predictive, but what we can do is, and what I used to call hotspots, essentially hotspots on the landscape, you can call it like a risk map, but essentially using all that data and the deer occurrence data coming out from the model to narrow down on areas that would be, and one of the things, it's again like your adaptive sampling. This is an adaptive management approach. This can all be updated based on like newer information coming in, and we can compare how our change how the change in our understanding is affecting the change in the patterns. But I do think the next step has to be incorporating rasters of geographical features in the very same model to kind of narrow it down to areas that we can kind of like, another point I think has been missed all this while, not only by me, but even most of the other researchers, modelers working in this is urban deer population. I think that is a huge issue. We haven't really, even forget CWD, even from management of those populations, so going back, I think I just want to highlight some of the possibilities that are possible with just this version of the model. Yeah.
It's pretty exciting. Like, and I wish Stuart Lichtenberg was here, but
Yeah.
there's great soil maps, right?
Exactly.
Soil maps.
Exactly. Yep.
That,
And that is a raster that is just added to the very
Yeah.
existing without changing anything.
and we know things now about clay-rich
Clay and-
soils,
yeah.
loam soils, and how those could influence prion
Right.
binding and infectivity. And
Right.
so there's a lot of information
There
there that we
is.
could actually leverage.
And if I can, because I think, we are kind of talking the same, can I go back to my screen and then come back to yours? But I just want to show you something that I might forget later on, and that's why I wanted to do that. Okay. I did not share. Yep. Share. Oh, here, sorry. Share. And then, so on this web page that I have shared with you, I have put in a lot of information after today's workshop part. And if you just all keep going down, I hope it is there, but there are some of the papers and some of the work that we were doing. I think there should be a map which shows environmental. Okay, it's not here, but I'll bring that up. I'll bring that up on another screen later on. Just maybe if you remember, tell me about that. But what it shows is, you can go back to your screen. Yeah, what it shows, what that model interface shows is how the prions that are deposited by infected deer, we have put in conditions like the prions remain viable for 2 years, right? Now that is like a very broad kind of thing, but there is possibility of changing that based on the raster that we incorporate, right? But even with that 2-year thing, think of this as because this is an agent-based model, the contamination and what in the disease epidemiology world is called the pathogen pressure. So how many infectious prions are there in the environment, right? Now that, for an agent-based model, is a function of how long does that infected deer live. Not all deer live all those 16 months, right? Some are killed the very same harvest season. Some die, and all of that is in our model. So the pattern of contamination that you see in the model landscape, there are a lot of possibilities that you can further refine it. Even though it is not predictive, it can help us understand things like, if we change harvest in this particular way in an area where CWD is endemic, right? What is the best strategy to minimize environmental contamination? Those are the kind of scenarios that I haven't thought of, but those are possibilities. Because all these years I have been working with agencies who recently detected CWD. And because of that, I had to focus on the pre-establishment phase of the CWD trajectory, and where, the agencies were not ready to get to a point where environmental contamination plays an important role. It would have just added a lot more stuff to the model. It is ready, it is published, it is just a matter of bringing it into the model, but we need a scenario, we need a setting to do that.
I think this is so exciting because, we've been talking about, working researchers that and for us in Minnesota, it's the MinPro team, what we're discovering, and how these prions circulate in the environment. And we have data now coming out of Wisconsin that Stuart is working on, showing 16 years after the prions are put into the environment, they're detectable and they're still infectious.
Yeah.
Which agrees with other,
Right. Right.
TSEs like Scrapie. And so this is a really exciting time because you can work,
Yeah.
like in our example with the Minnesota DNR, who have, years now of data, and what we're finding on the ecological, the environmental side, and then putting it all together is super powerful.
Perfect. Yeah. And the reason I kind of digressed here is henceforth now and in the next session, please keep thinking about scenarios or questions that would be relevant. And before we go any place, I just want to make sure that all of you, and at least some of you, start the runs so that, maybe by the next, the second workshops mid, you would have data for 100 iterations. Okay, so what I'm kind of going to go back, just set you all up with the behavior space and then come back and then talk about it. So first step, go to the results folder and delete the file that is written there. Results folder now, not the data folder. Yes, sir.
Oh,
Yeah.
Too far past that. What is the brown area?
Ah,
There's just no deer there.
great question. I'll tell you. That's a great question. I should have, and thanks for bringing that up. Okay, so most of the agencies in the Midwest and this part of the country, you have counties as your management units. Not so in the West. Like you have deer management units or whatever, they are larger areas. But most of the agencies here are okay with counties. And so we decided to have county as a unit. It brings up two problems. And I'm glad you brought that up because these are the questions I should actually clarify earlier on. So we are just limiting our simulation to a county, which is like an administrative border, right? So the brown patches are not in our model. But that brings up a question like deer don't understand the boundaries. A deer that is out here very well uses like this part. A deer that is out here probably uses this part. So we have found a way out, okay, for the purpose of modeling. And when you run the OVPOP model, you will see some of the deer change their color to blue. I don't know if you noticed when you run OVPOP, some of the deer change their color to blue. Those are the deer that disperse out of this county. Now, NetLogo has a peculiar kind of, a feature, which is called wrap the world. So in our model, the world is wrapped. Anyone going out from here enters back from here. So we make an assumption that the number of deer dispersing out of our model is equal to number of deer coming into our model, right? So any deer that goes out here comes back in here. But it comes in as a new deer. It changes all its state variables and comes in as a new deer. That is one way to deal with the spatial problem because, this is artificial, right? This is all artificial. And so you are asking about these brown patches?
Yeah, like just.
Right.
Bottom right side of the.
Is this your screen, Peter?
Yeah.
Can you right click on one of the patches in the model? Yeah, that's fine. Yeah. And inspect patch. Yeah. And so it opened a window on your, okay. Right. And so if you look at this patch variable, which is DO, so the patch variable, the % forest there is given here. This is based on the GIS data. DO tells us that this is a patch, which is a deer habitat. So deer can occur on that patch. That is again based on all the using the information. If you scroll down, okay, this DH is the, this DH is the deer home range number. So we kind of make sure that whatever we are simulating in here in terms of deer home ranges, it's not uniform, but it does match with the data that we know. So that's all a part of the code. That's all fine. If you can now click on the black patch, you can click on here, right click, and inspect that patch. It should open out a similar window. And if you could bring that, And now notice that the deer occupancy is -1. So that patch is not a suitable deer habitat based on percent forest cover, based on whatever other GIS information available, right? And it's not a part of a deer home range as well. So we have used whatever published data is available for the Midwest mostly to simulate deer occupancy and deer home ranges. The patches that, so maybe you can go back to the interface. Right. You clicked on the black patch, right? And you can click on the brown patch now, right click and inspect patch. And you can just tell us, you don't have to share that window, but what you see on the DO and the DH.
So when you right click on a brown patch, the DO is 0 and the DH is -1.
Right, right. So essentially it's a combination of the percent forest cover and the geographical administrative border of the county that gives you that. So the black and the brown patches are different. I believe the black patches are the part of the county, but they maybe have a lot of forest, or they have a very few percent forest, very low percent forest cover.
How would water features look? Water features.
We haven't added that, but we can add that. But water essentially has no forest percent forest cover. So it would come back to 0. So it would be range between brown and black. Yeah.
So like, if I have cropland or CRP land, there's no forest cover, but we have fairly high deer populations
Yes.
on those.
So that's a good question.
Do I have to like
No,
say it's
no,
forest?
I'll tell you what it does. It does not look at individual patches. It looks at a patch and a neighboring patches to decide whether it can be a part of a deer habitat. So based on a very simple rule of thumb from Hewitt's book, like, you know, the chapter where you see 25 to 75% forest cover, you know, deer occur between that, but we don't limit it to one patch. A patch, as you said, is cropland, but neighboring patches has a higher percent forest cover. Then the combination and average of those patches gives you a mean value for the locality. And if that falls between 25 and 75%, it is treated as deer habitat. So it's not based on if one patch is 1 square mile is just cropland and no percent forest cover, but one of the neighbors or few of the neighbors have like a percent forest cover. Together, adding all of this together gets you between 25 and 75% for the locality. It becomes a deer habitat. So even if there are farms, but if they are extensive, then so you need that edge, right? The forest and the farmland and the combination of that.
I live out in have a house out in Northwest Iowa. They're just
Right.
it's deer.
Yeah.
You know, and so like, but they'll live in like CRP.
Right,
if you get a
right.
ditch or whatever, that's where they'll hang out. And I was thinking of like, in South Dakota or something.
Right.
Like it's
And
like-
you are right. We can very easily adjust that to represent the area based on what we know about the area.
Sure.
So this is basically started as a Midwestern kind of, scenario where you have all of that, but it's very easy to update that. There is no change in code. It's just the rule that we change.
I'm
Right.
wondering if GIS, like USDA land coverage data, is it going to be fine enough to say like, actually there is a patch forest here? Or if you try to report that and then considers it not suitable for habitat?
So let me skip to a part that I was going to bring up later, because I think this is a very relevant kind of question. Yes, please. So let me go back and open. I will open it from the links I have provided you, but we will explore that later in the second workshop. But this is another Shiny app we came up with exactly for the questions that you are asking. And this might not be the final answer, okay? But if you look at this, what area were you referring to? You said Iowa.
Sure, like,
Let's look at Iowa. Let's look at it. So let's select Iowa, which is IA. Okay. And do you think any county in mind?
um,
So you will see the names of the counties on the right hand side. Yeah. Which one?
trying to think of one.
Shelby, Lynn, Jackson.
Not those. Let's go to, let's pick Sioux County. Relatively,
Which one?
SI,
Okay. So
Pocahontas would actually be good.
wait,
Go back to that.
this one?
Yeah.
Okay. Right. So let's plot the county. You should see that here, just the outline of the county. Okay. It's a square one.
They're all the same.
Land cover data. Yeah. Yes. Right. So I just because of the sharing thing, these are all the layers available from the USGI or whatever US. We have just selected evergreen, deciduous, and mixed, but shrub, grassland. You tell me which is the deer habitat. It's just a matter of selecting those layers in the map. And
Do you share your screen?
my,
Recreate.
my bad. Yeah.
Zoom folks, we're gonna recreate this. It's pretty cool. You can actually import land features through his Shiny app.
Okay. Do you want me to go back? Sorry, Zoom participants. I just kind of missed on that. Okay. So with this, this is in the link that I have shared with you, but please don't everybody log on that right now. But it is in the link in the web page. It's called Get ASCII, the very first link on there. You are able to select any of the 50 states here. We have chosen Iowa. It gives you the names of all the counties in this box. You just say save state and year, and then those counties are available here in select county. We selected not Decatur, okay. And then we can actually plot the county outline, which, as you said, it's a square one, so nothing to look at that there. Land cover data, and the land cover data gives you, okay. Yeah, so the land cover data here will tell you what all land cover is available. Right now, we have just selected the 3 forest types. But if you think that is not the right way to do it, then we can change that easily. Select the ones that we think are deer habitat there. And then this is forest cover. We could add grassland, we could add cropland or whatever you want. That brings in our model landscape. So this is how the percent forest cover, this thing converted into percent forest cover for a square mile grid looks like, right? And this all can be adjusted, right? But we can select grassland and crop things here and then get a land cover data for that selected attribute. This goes into the model and it follows the exact same rules that we have done for percent forest cover. So
Can we do Minnesota?
oh, we can. And I was planning to do that in the, but let's do it. No, let's take a look.
All right, real quick, we're gonna look at Minnesota,
Minnesota,
Houston County.
I thought it was weird because of a very low percent, not very low. I think something was different there, but we'll see.
And then we're gonna break for lunch.
So MN, right? And 2021, you have the option of selecting like whatever other database, NLCD database, but are we into Minnesota now? No. Let's take a look. Yeah, which one? Houston. Did I miss it anywhere or it's still down? Oh, here it is. Houston, Lott County. Okay. Is that the correct shape?
We're all laughing because we don't know the shape of Houston County.
Yeah, I
Yeah.
think that was the other one I selected first. Yeah. So this is it and this is it. Yeah. See, there is a lot more green thing than the Iowa ones we looked at, right? So it's just I have a problem. I don't know, you use Shiny apps, right? So my hope was this downloads the ASCII file on my laptop. But if I ask it to do on the user's laptop because of security reasons, Shiny app does not provide access to local computer folders. So a way around that is this file can be emailed to the user. But if you know of a way of the Shiny app, the user being able to download it locally, we could try that. But this essentially gives you the ASCII file for the OVPOP model. You can just import this into the OVPOP and start the process of calibration for any county in Minnesota. Yeah, anyway, so
All right, with that, we're gonna go ahead and break for lunch, and this, the second workshop starts at 2 p.m. So that's when we'll go live, 2 o'clock. Thanks everyone on Zoom. We'll see you
thank
soon.
you.